distillation. Distillation is the process of heating a liquid to form its vapors and then condensing the vapors to form the liquid. It is used to separate two or more substances present in a liquid or for purification of water. The apparatus used for distillation is shown here. Let us see the demonstration. Take some salt water in a retort and heat it till the water gets converted to steam. The steam is collected in the beaker, which is connected to the retort as shown here. The steam condenses into drops of water and the salt is left behind in the retort.
In this video, you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars; naphtha, used in the manufacture of chemicals; kerosene as aircraft fuel; diesel oil, used as fuels for vans, cars and lorries; and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling point. You should understand that small chain molecules are collected at the top of the column since they have lower boiling points, and larger chain molecules are collected further down the column as these have higher boiling points.
Our topic for today is chromatography.
Please take my cup. Please, get me the schedule.
Does black ink consist of only black color or any other color as well? Let us find out by the process of paper chromatography. Chromatography is a technique of separating two or more dissolved solids, which are present in a solution in very small quantities.
Wake up. Wake up. Please come here.
Yes.
Please, wake him up. Do something. Wake him up.
Take a strip of filter paper. Draw a line with a pencil close to the lower edge of the paper.
No response.
Please, call the dropper. Please, wake him up.
Put a small drop of ink on the center of the line. Let it dry for some time.
No response.
Call Mr. Smart. Please, wake him up.
Take a jar containing some water. Put the filter paper in it, such that the drop of ink is just above the water level.
No response.
After some time, the water starts gradually rising up by capillary action. As the water moves up, it takes the dyes present in the ink along with it. As the water rises up, we see different colors on paper. These are the different dyes present in the ink. Different dyes have different solubility levels and travel at different speeds as the water rises up. As a result, we see different colored strips at different heights, and the dyes get separated. Hence, paper chromatography is used to separate the different colors in a dye.
Solutions, suspensions, and colloids. You will learn the difference between a solution, suspension, and colloid. What is a solution? It is a homogeneous mixture of a solute in a solvent. Solvent, the substance in which a solute dissolves. Solute, the substance that dissolves in a solvent. Solvent is the substance that is present in the greatest amount. Both solute and solvent can be a gas, a liquid, or a solid. Activity: mix a spoonful of salt in water and dissolve it. Here, salt is a solute and water is the solvent. On dissolving, you will observe that a clear solution is formed and there are no salt particles to be seen. The salt solution thus formed is a homogeneous mixture. What is a suspension? A suspension is a mixture of water and a non-dissolved material. The mixture separates on standing. Take some water in a glass and add a tablespoon of vegetable oil. You will notice that no matter how much you try, the oil does not dissolve. On standing, you will see that oil separates and settles at the bottom. Such characteristics are that of a suspension. What is a colloid? A colloid is a solution in which the substance remains dispersed and doesn't settle at the bottom. It consists of two components, dispersion medium and dispersion phase. Here is a list of different types of colloids that are formed due to different types of dispersion phase and medium. Activity: take a spoonful of flour and mix with water and allow it to stand. Now, drain the water. You will notice that after draining, there are still few particles suspended in the solution which refuse to settle. Such a solution is termed as colloid. Summary: a solution is a homogeneous mixture of a solute in a solvent. A suspension is a mixture of water and a non-dissolved material. Colloid is a solution in which the substance remains dispersed and doesn't settle at the bottom.
Distinction between solutions, colloidal solutions and suspension. Size of particle. The solute particle in true solutions are molecules having diameter less than 1 nanometer. The particle size in colloidal solution is from 1 nanometer to 100 nanometers. The size of particles in suspension is greater than 100 nanometers. Visibility of appearance. The solute particles are invisible to the eye as well as microscope in true solution. In colloidal solution, the solute particles are invisible to the naked eye, but can be seen with a microscope. In a suspension, the solute particles can be seen with naked eye as well as with microscope. Settling. The solute particles in true solution do not settle. The solute particles in colloidal solution can be made to settle by centrifugation. The solute particles in suspension settle under gravity. Filterability. The solute particles in the true solution diffuse, pass through filter paper and through parchment membrane. The solute particles in a colloidal solution do not pass through parchment membrane but pass through filter paper. The solute particles in a suspension do not pass through parchment membrane or filter paper. Tyndall effect and Brownian movement. True solution shows Tyndall effect, no Brownian movement. Colloidal solution shows Tyndall effect and Brownian movement. A suspension may or may not show Tyndall effect.
Brownian movement. When colloidal salts were observed under a microscope, scattered light was seen moving in a zigzag motion. As the light is scattered by colloidal particles, these particles execute ceaseless, erratic random motion called Brownian movement. It is due to the bombardment of colloidal particles by the molecules of the dispersion medium. Due to Brownian movement, the colloidal particles do not settle down under the force of gravity, and therefore it is an important factor for the stability of the sol.
Tyndall effect. A colloid scatters a beam of light passing through it. It means that a beam of light passing through such a colloid is visible. If a beam of light passes through a colloid kept in a dark room, the path of light can be seen due to the scattering of light by colloidal particles. The same effect can be generally observed when a beam of light passes through air containing dust. This scattering of light by colloidal particles is known as Tyndall effect. This effect is not shown in true solutions. In liquids, the Tyndall effect can be easily seen by using a laser pointer. If you dilute milk to where it is almost clear, or if you have any type of solution, such as colloidal silver, then the beam of the laser can be easily seen as it travels through the liquid.
Today we discuss about the topic emulsions and types of emulsions. Let's first discuss about what are emulsions. Here is the definition. Emulsions are the colloidal solutions in which both the dispersed phase and the dispersion medium are liquids. Emulsion are liquid-liquid colloidal systems, that is, the dispersion of finely divided droplets in another liquid. It may be noted that any two immiscible liquids forms an emulsion. Here is an example. Milk is a naturally occurring emulsion in which the particles of the dispersed phase, that is liquid fats, are dispersed in medium, which is water. Emulsion is generally unstable and the two liquids may separate out on standing for some time. You can see here oil and water are separate out after standing for some time. The resultant is they form different layers. To form stable emulsions, small quantities of certain other substances are added during their preparation. The substances which are added to stabilize the emulsions are called emulsifier or emulsifying agents. Some of these are gum, gelatin and soap of different forms. Let's discuss about what is emulsification. The stabilization of emulsion by means of emulsifier is called emulsification. Our next topic is types of emulsions. There are two types of emulsions. The first one is oil in water type emulsion and the second one is water in oil type emulsions. Let's first discuss about oil in water type emulsions. In this case, oil acts as a dispersed phase which is in small amount and water acts as a dispersion medium which is in excess amount. For example, milk is an emulsion of soluble fats in water. Such type of emulsions are called aqueous emulsions. Here you can see oil is dispersed in water, where oil acts as a dispersed phase, where water acts as a dispersion medium. Second type is water in oil type emulsions. In this case, water acts as a dispersed phase while the oil acts as a dispersion medium. Example, butter and cold cream. Such type of emulsions are called oily emulsions. In the figure you can see here, water is dispersed in oil. Water acts as a dispersed phase while oil acts as a dispersion medium. Thanks for watching.